Good morning, everyone. I hope you all can hear me. Uh, Please let me know if you can hear me. Please let me know that if you can hear me. Right. Okay. Thank you very much for responding, and it looks like that everyone can hear me. So today we are going to under introduction to basics of electrical engineering. Today we are going to discuss about a new topic, and you should know by now that this course title has been changed to introduction to electrical power, right? Earlier it was basics of electrical machines, sorry, not in engineering. Earlier it was basics of electrical machines. Now the course title has been changed to introduction to electrical power, right? And the course code remains still the same, and the number of credits and all the other things are going to be there as same as before, except the course content and the ILOs. Course intended learning outcomes, or as the purpose of this course has been kind of improved a little bit, and the content as well, right? So I believe that you have gone through the course plan by now. And if you cannot still access to the LMS and access to the recorded videos, please let me know. Yesterday there was a kind of a uh, comment from a student about accessing the LMS, that the student cannot download the videos. So the problem was like, I believe the folders, once you click on the folder itself, they are not going to expand. You have to click on the arrow to the left of the folder, recording folder. There is a the recordings are shown as a tree of folders. So that was the problem. So somehow what I did was, like, in the options I expanded the view. Right now I think you can see directly what is inside the folders, so you don't have to click on the arrows. I believe that it's much convenient, and you can download the videos now. So please let me know that if for some reason if you cannot access, and you have to kind of regularly check the LMS. So that is one reminder. And today, according to our course plan as well, today our discussion is about the review of electrical systems, so which is a new topic. And I believe now you can see my screen. Should be showing a Google browser. And of course, whenever you have a problem, you can message me. Can you hear me now? And thank you for letting me know that. If you have any hearing issues, please let me know. So, can you all hear me now? So please let me know that if my voice is not clear. Okay, right. Thank you very much. So, right. Thanks for the responses. And I believe you can see my screen as well. I have just now shared the screen with you. And as you can see, the topic is review of electrical systems. So the course title has been changed, as I told you. From earlier, it was basics of electrical machines. Right, this was the machine something. Right now, this has been changed to introduction to electrical power. Right? So this is the new course type, and all the other things remain except the course content, right? So, and electrical machineries, the things we have learned so far is also a part of this course. So don't worry about the uh, title being changed, right? So nothing, it's not going to affect our teaching, learning activities, right? So under that new course module, so we have introduced some new things, new content about the electrical power systems. So there, uh, we're going to learn about electrical power system, the basics of electrical power. And before going to the electrical power aspect, power related aspects, I'm going to discuss a little bit about what it is meant by an electrical system, right? The systematic approach. And systematic approach in the sense, so this is something I found on the internet definition, and it says a system is a group of interacting or interrelated entities, right? Interacting or interrelated entities that form a unified whole, right? So the idea is, like, for an instance, if you think of the electrical system of an engine of a car, so there are several individual entities. So engine is a one part, and there is a battery. So here we are kind of highlighting the electrical system of the car, not all the parts. So the battery is a part of that, and there is a voltage regulator and control and measuring devices, in the sense there are some speed measuring devices, maybe electrically measuring, and fuel level measurements, and there are many other sensors, right? And of course there are actuators as well. Sometimes your braking system is working with some actuators, some are electrical, and there is a generator. So there are the what it is meant by being a system is that these individual components, right, are acting as part of something big, right? And when you consider this entire thing, it has a purpose. It has maybe more than one. It may have several purposes, right? But when you think of these entities individually, right, a generator alone, right, would only do generating electrical energy, right? So converting some other form of energy to the electrical form. Once you integrate it into a system, you can use it. And without a system, this individual entity may not have any purpose, right? Same for all these other entities. So the idea is that a system is composed of several individual entities, and they are functioning as a whole, not individually, and there is a particular purpose for their for them to have a system, right? For these individuals to have a system, there has to be one or more purposes, right? Other than that, there is without a purpose, we don't need to have a system, right? That is the basic idea. So with that idea, right, when you think of an flashlight, maybe you know about a torch flashlight, so you have seen this, maybe you have one at home. So at its simplest form, this is an electrical system, right? So basically, if you look into a flashlight, look inside of the flashlight, so it has a, in terms of electrical engineering, we can focus that it has a bulb, a light bulb, and some conductive parts, and a battery, right? And a switch. So those are the individual entities of this system, right? A bulb, a switch, and a battery, right? And of course, there are conductive parts. And in terms of electrical engineering, what it is important for us is are these components, right? Is only these components, right? And we can, the same flashlight, right? We can model it in terms of electrical engineering like this, right? So for some reason, if you have to uh, analyze or solve a problem related to a flashlight, right? So you are not going to go for a diagram like this, but something like this. And let's say, okay, you are going to control the amount of light that is coming out, right? So you need to write some equations which are kind of coming from the basic principles of electrical engineering, and you're going to look at a circuit like this. So the switch is kind of denoted, this switch is denoted like this, a bulb is that is shown here is represented by this symbol, and batteries with these symbols. So likewise, we are making everything simple. At the same time, we are going to use the basics of electrical engineering. For an instance, if someone wanted to find the amount of light, uh, you may have an equation which is related with the amount of light and the current through this circuit, maybe, right? Or else the voltage across the bulb, right? You may have relationships like this, right? And you would write some equations, which means you are mathematically trying to model this situation. And then you may be able to kind of make this voltage at the battery a variable and write some equations, and you can analyze by using this circuit, right? In order to have let's say particular amount of light, what is the amount of voltage you need there, something like that, right? So the basic idea is this analysis of real world situations in on the electrical engineering principles we do by using circuits and the basics of electrical engineering principles, right? And it's not only for simple systems. So if you think of a complex system like this, right? So what you are seeing here is uh, the process, or as they are the electrical utility grid, so which gives the electrical power to your home, right? So we call that electrical power system. Of course, this is an electrical power system. uh, in usual terms, we call it electrical utility grid, right? And your home is connected to the electrical utility grid. That's how you get the electrical power to your home, right? It's a really complex system. The controlling and monitoring and everything is really complex. There you have a generating station. So usually we call them power plants, right? Power plants. In Sri Lanka, the usual term is power plants, but of course, generating station is a uh, accepted word, right? And there you have something called as transformers, so which convert one voltage level to the other. You may have heard already. And then there is something known as a transmission lines, right? And there the voltage, this electricity is transferred from the generation point to something known as substation, where a place which is located for a considerable area. Maybe for Anuradhapur area there is one substation, and for Polonnaru there is another, likewise. And from the generation point, let's say for an instance Noracholi, so from Noracholi to Anuradhapur there is a transmission line. This is not actually how it is implemented, but for the time being, let's think in that way. And we are in, uh, during this transmission process, they are using high voltage, and from the transformer, what would happen is the substation transformer here, what would happen is the voltage is going to be lowered, right? Here the voltage is increased. Since the voltage at this side, right, input is lower than the output, they are called step up transformers. And when transmitted, there the voltage is at the input is higher than the output, so which means the voltage is dropping, so therefore they are called step down transformers, right? And from there onwards you get this low voltage, which is at about maybe 230 volt at your home place. And for the industry there are 11 kV and 33 kV as well. And if within these buildings you may have different utilities, like different loads, in other words, like machines, maybe televisions and lighting applications. There would be uh, thousands of applications of electricity in these buildings. So these are the utilization points of the electrical power, right? These are the generation. So basically this is what it happens in an in an any electrical grid. And it's a really complex thing, right? But if you are to model this situation, so it's again the things again narrow down to these basic principles, right? So somehow all these loads and everything you are going to represent by if they are linear, resistors, inductors and capacitors, right? If we assume the system to be linear, we are going to kind of denote all these loads using these components. And of course this transformer can be modeled using these three components. And this source here you are going to model as a, we call it's an AC source, some sort of AC power generation point, right? So these conductors again are simply conductors like in a circuit. So which means this entire system at some point we can denote it as a circuit, an electrical circuit. So the basic idea is, without knowing the basics of electrical principles, or as the basic electrical principles, we cannot solve problems in the field. So therefore, although maybe when you learn these theories and principles you may feel it like they are not going to be helpful or useful in your life, so they are going to be useful, right? So for an instance, the things you learned in the first year are going to be useful in second year, and the things you are learning in the second year may even have industrial applications, right? So that's why we are learning these things. And this, as you know, this is a professional degree, so things you learn here may someday have the chance of you may have the chance of applying these things in the field, right? Right. So I believe the purpose of this content is clear now. And as I said, told you earlier, uh, you have to focus like that. We have to gain and improve our knowledge and skills in basics of electrical principles and theories. That's what we are trying to do here. And you have to kind of by yourself allocate your time and pay some attention to improve your own knowledge, right? So that's about the basics and the purpose of this electrical systems. And let me start a new part here. I hope you can still see the screen. So the first thing we are going to learn about is that as a review, so most of these things are you already know, I believe, but I'm going to kind of I'm trying to kind of refresh your memory on these aspects today, and because these essentials are again very much a kind of without these things you cannot progress through these subject matters to come. So that's why I'm trying to refresh your memory on these aspects. So the first thing I would like to discuss about the sources and of power, right? So different sources of power, and as a very important thing. So in electrical engineering, you should know what is an EMF, or as electromotive force, and what it is meant by potential and the potential difference. So for an instance, right? Let's think of a 5 volt, an ideal battery connected with 1 ohm and 4 ohm resistance, right? So in this case, you should know, okay, there is a current flowing through this circuit, right? So in reference to this circuit here, right? If if I would ask you, right? If I would ask you what it is meant by electromotive force, right? So I think the wording is here. So electromotive force, right? You should give the idea, you should have the idea that it is the ability to, right? This word is important, ability to move charges, right? So the idea is there are positive and negative charges. So electromotive force, in the sense, this battery has the ability to push these charges, right? And they are going to so go through these conductors and reach the other side and be neutralized, right? So the idea is that the electrical pressure, in other words, it's about the electrical pressure. So I'm sorry, I just this is 1 ohm and 4 ohm, two resistors connected in series with a battery, right? And the next thing is the then if electromotive force means the ability to move charge, what does it mean by uh, potential, or the ability to so potential in the sense is the ability to do work, right? Ability to do work defined for per unit charge, right? Per unit charge. So it means something like this, right? So we simply so far known voltage, right, as a different quantity measured with the unit volt, right? But what it says here is, so for potential and voltage are the same, right? That is again something you should know. What it is, what this statement says is, it is the ability to do work, which means this has the voltage has some relationship with joules, right? The unit of work or as energy. Of course, it has, right? So for an instance, the definition is something like this. So before going to that definition, I would like to give you a question like this. Let's say there is a staircase, right? And here this height is 0.1 meters, this height is 0.05 meters, and this again is 0.05 meters, right? And I'm going to roll a ball with a mass of 2 kilograms. You can take the gravitational acceleration as 10 meters per square second, right? G is this much. And I'm going to name these points as, this is point A, this is point B, this is point C, and this is point D, right? So I have given you the heights. So in this case, if you move a point from, if you move this ball, right, from, if you, let's say you had moved this ball from this point here, point C to A, right? You are moving the ball from point C to point A, right? So my first question is, at which point, at which point, at which point does the ball has higher potential? Higher potential. Higher potential energy. Point A or Z? A or C? So you can answer now, is it point A or C? At which point? So the thing is, you have moved this ball from point C to point A. So at which point does it have higher potential? So is it at point A or point C? So you're moving a ball of with a mass of 2 kilograms. I only have got two answers. Okay. I believe the question is clear. Uh, Answer A is point A. Answer B is point C. I'm going to launch a poll so you can answer. Right. Answer A is point A. Answer B is point C. So which point has the higher potential? So at which point does the ball have higher potential? Point A or point C? Answer A is point A. Answer B is point C. Right. So around 5 students are saying it's answer A. So okay. Kind of uh, happy. Many students are saying that point A has the higher potential, right? Point C has the lower potential, and the gravitational force is acting in this direction. So higher potential energy, as you should know by now, is at point A, right? So here the ball has the higher potential energy. So which means if you are moving from point C to A, which means at a lower potential to a higher potential, right? the amount of work you have to do is, you have to, of course, to do work on the ball, right? And if you release from this point, if you release the ball from this point, it would do work for you, right? So this is something you should have known by now. If you don't know this uh, by now, you have to kind of refresh your memory on physics subject you had done in the first year, and all the physics related problems you have solved in your advanced level, right? And now I want you to find the amount of work you have to do when you move from point A to C, right? Find the amount of work you have to do when you move from point C to point A. Amount of work you have to do, right? So find it and tell me. Right. So one student has sent an answer, right? Let me say, okay, answer A, answer B, answer C, answer D. Answer A is 5 joule, answer B is 3 joule, and 30 joule is there, 40 joule. So these are the answers you can have. Uh, what is your answer? Is it A or B or C or D? So answer 3 is 30 joule. Right? So only 3 or 4 students have given the answers. I don't know what has happened to the others. So it's a very simple and easy question, right? And advanced level theory. So by now you should know the equation you use for this thing is energy is mgh, right? So you're moving the ball from point C to point A, which means the height is this amount of height plus this much. So which means 0.1 plus 0.05. It is the total height is going to be therefore 0.15. Unit is meters, right? And you are going to substitute this 0.15 meters as the height. You know the value of G. You are going to use the uh, international metric units, and M is given here directly. This is M. Substitute and let me know what is the amount of work you should do. So still there are two students who have given, I believe, the wrong answer, right? So which means you have improved your basic knowledge on physics, right? So you have 3 more years to go, right? So you are still at the second year, so you can improve therefore. And thank you very much for the answers. uh, Whether the answers are correct or wrong, giving the answers is more important, right? So this, that way you know that making mistakes means that you are progressing, right? වැරදි කරන තරමටම හදාගන්න පුළුවන්. ඉතින් ප්‍රශ්නයක් නැහැ. හැබැයි මේ දැනුම ඔයාලට තියෙන්න ඕනේ potential කියන එක තේරුම් ගන්න electrical engineering, right? So now you have some idea about, you have refreshed your knowledge about this potential energy. Now let's see what it is really happening here, right? You have to do work here because there is always a force, right, acting on the ball downwards, which we call as the weight of the ball, right? In other words, the ball is always attracted to the earth, right? So there are, it's like that, there is a rubber band, right? The ball is attached with a rubber band to the earth, and you are trying to pull it away. Right now, this is a rubber band, right? The feeling is something like that. I'm not saying that the ball is physically actually attached. Feeling is something like that. හරියට රබර් බෑන්ඩ් එකකින් බෝල් එක පොළොවට තියලා අල්ලලා තියලා වගේ තමයි අපිට දැනෙන්නේ. අපි මේක උඩට ඇදන් යනවා. Right? That is the feeling. ඇත්තටම එහෙම තියනවා කියන්නේ මම කියන්නේ ඒ වගේ සිද්ධියක් තමයි තියෙන්නේ. Then what would happen is, as you stretch this rubber band, there would be some energy stored as potential energy. Rubber band එක ඇද්දාම potential energy එකක් එකේ තියෙනවා. As you release it, what would happen is it would come back to its original position, releasing that stored energy to the outer world, right? මේක දැන් බෝල අතෑරියොත් rubber band එකකින් මොකද වෙන්නේ? rubber band එක stretch වෙලා තියෙන්නේ. ආපහු rubber band එක ඇදලා අතෑරපුවම වෙන දේ අපි දන්නවා කවුරුත්. The same thing is happening because of these gravitational forces, right? So that's why we we name them as potential energy, right? This energy we name as potential energy because it's the same thing happening like in a rubber band, right? Now what I'm trying to do is, let's say this is a process where I have to move different sizes of balls, maybe 2 kilogram, 5 kilogram, etc., right? So then what I'm going to do is, I'm not going to use this equation all the time, right? I'm not going to use this equation for all the time. So I'm going to name these, sorry, A, B, C, D points, right? I'm going to name these A, B, C, D points as per unit potential points, right? In other words, I'm going to name, okay, I'm going to take this point as my reference, I call, right? I'm going to take this as reference. You would get the idea of reference later. Reference. And this point C is the reference point now. And I name at this point, the amount of energy the ball has is 0, right? Is 0. It is 0. I'm going to name it as 0, right? 0 joule per kilogram. Per kilogram, right? If I put a kilogram ball here, the amount of energy it has a 0 kilogram. Now, can you tell me what is the amount of energy you have if you put a 1 kilogram ball here at point A? So what is the amount of energy you have? So per kilogram energy, I'm asking. So if you bring a 1 kilogram ball from point C to point A, what is the amount of energy you would have? මම කරන දේ පොඩ්ඩක් සිංහලෙන් කියන්න. මම දැන් කරන්න යන්නේ මේක ජූල් වලින් නැතුව කිලෝග්‍රෑම් එකකට ජූල් කීයක්ද කියලා මෙන්න මේ පොයින්ට්ස් ටික නම් කරගන්න යන්නේ. මම රෙෆරන්ස් පොයින්ට් එක විදිහට. ඒ කියන්නේ බිඳුව කියන්නේ මෙන්න මෙයා කියලා මම C නම් කරගන්නවා. C වලදී තමයි බිඳුව වෙන්නේ. එහෙනම් A වලට කිලෝග්‍රෑම් එකක් අරන් යද්දි කරන්න ඕන එනර්ජි වර්ක් ප්‍රමාණය හරි නැත්නම් වැඩ ප්‍රමාණය හරි කාර්ය ප්‍රමාණය හරි නැත්නම් A වල තියෙන බෝල් එකදී කිලෝග්‍රෑම් එකක් බර බෝලයක් C පොයින්ට් එකට සාපේක්ෂව තියෙන එනර්ජි ප්‍රමාණය ටක් ගාලා කැල්කියුලේට් කරලා කියන්න. Right, it's 1.5 joule, right? And per kilogram kilogram එකකට 1.5 joule කරන්න ඕන කියලා අපිට නම් කරන්න පුළුවන්. ඒ කියන්නේ point C වල ඉඳන් point A වලට මොකක් හරි වස්තුවක් අරන් යනවා නම් කරන්න ඕන කාර්ය ප්‍රමාණය 1.5 kilogram per joule. Sorry, joule per kilogram. Joule per kilogram. Likewise, for point B, you can say, okay, it is 0.5 kilogram per joule. Sorry, joule per kilogram. Joule per kilogram. And right now, let's say someone just come and now you there is, let's say, okay, there is a process where you have to kind of bring balls from starting from point C to different other points, right? Point B and point A. And a person comes to you and say, okay, I have a 150 kilogram ball, right? Amount of load, right? Amount of something, or an object with a mass of 150 kilogram. And I want you to move it from point C to point A. So without going for this equation, right? Now, since you have this energy points given, right, for different levels, right, per kilogram energy points given. Let me make this image clearer for you. You can easily calculate those values. So this is 1.5 joule per kilogram level. This is 0.5 joule per kilogram level. And this is 0 joule per kilogram level, right? And as earlier, this is C, this is B, and this is A, right? Now the amount of load you have is 150 kilogram. You don't have to go for this mgh equation. So now what you simply do is you have amount of amount of work that need to be done per kilogram. So you simply multiply this level per kilogram work amount, right? In other words, joules per kilogram level by this mass. So which means you simply multiply 150 by 1.5 if you want to calculate the amount of energy from point C to A. And if you want to calculate the amount of energy from point C to B, that has to be 150 multiplied by 0.5 joules, right? Right. So I'm really sorry, I have to draw everything from the beginning. This is 1.5 joule per kilogram level. This is zero point 0.5 per joule per kilogram level. This is 0 joule per kilogram level. And I'm not going to this point yet. These points are A, B, C, and D. So a person comes to you and say, okay, I have an object with a mass of 150 kilogram, right? I want you to bring this mass from point C to point A. So what is the amount of work you should do, or else what is the amount of energy released, right? So that is the question, right? So as I told you, all you have to do is I name this as the energy level, and all you have to do is mass multiplied by energy level, right? So that is, now you make the things easier for your process, right? So because you know that the heights are not going to change or something like that, right? So in this process, let's think of a real world situation. Someone comes to you and asks, okay, I have 250 kilogram object load. Please calculate the amount of work you need to do. If you bring this from point C to point A, please quickly send me your answer. Now don't go for MGH. So we have already defined these values from point C to point A, right? So calculate the amount of work you need to do from some point C to point A. මම පොඩ සිංහලුත් මේක ආපහු කියන්න. මෙතනදි කරන්නේ levels තියෙන අපි දැන් heights තිබ්බනේ. එතන එක උසවල් අපි දීලා තිබ්බා. අපි උසවල් දෙන්නේ නැහැ. ඒ වෙනුවට අපි කෙලින්ම කියනවා මම මෙන්න මේ level එක 0 reference level එක නැත්නම් 0 energy level එක කියලා නම් කරොත් 0 joule level එක කියලා නම් කරොත් මෙතන ඉඳන් මෙතනට B point එකට C වල ඉඳන් B වලට කිලෝග්‍රෑම් එකක බෝලයක් අරන් යන්න 0.5 joule work කරන්න. නැත්නම් C වල ඉඳන් A වලට ගෙනියනවා නම් 1.5 joule work කරන්න ඕන කිලෝග්‍රෑම් එකක බෝල එකට කියලා මම කැලින්ම levels ටික නම් කරනවා. දැන් මම ඇත්තටම GH තමයි මෙතන දීලා තියෙන්නේ. එහෙම දීලා තියෙද්දි දැන් මෙතන heights ඔය ඇත්තටම දන්නේ නැහැ. මේ උසවල් ඔය ඇත්තටම දන්නේ නැහැ. එක්කෙනෙක් ඇවිල්ලා කියනවා හරි මට C වල ඉඳන් B වලට C වල ඉඳන් A වලට බෝලයක් වස්තුවක් ගෙනහිල්ලා දෙන්න 250 kilograms තියෙන. මොකද්ද ශක්තිය වැය වෙන කියන එක තමයි අහන්නේ, right? Right. So different people are giving different answers, and thank you very much for the answers. Now all you have to do is mass multiplied by the energy level, right? So mass is 250 kilogram. I'm going to solve the problem for you. And 250 kilogram multiplied by 1 point. So you are taking from point C to point A. So the difference is 1 point this much. The difference between these 2 points, right? The difference between, so you have to think of here it's 0. So when you bring from C to A, you have to do a work for 1 kilogram, you have to do a work of 1.5 joule. So then you multiply by that value, 1.5 joule per kilogram. Now what would happen when you think of the unit? Here the kilogram is above the division line, here it's the denominator, right? So they are going to cancel out. The kilogram unit is cancelled out. So Now the final unit is in joule, right? The final answer is in joule. And you have to multiply 250 by 1.5. 250 multiplied by 1.5 means 250 plus 250 divided by 2, that is 250 plus 125, right? This you should know how to calculate. And the value is going to be 375. The correct answer is 375 joules. That is the amount of work you should do. And thank you, many have given the correct answer. And those who gave the wrong answer doesn't mean that you have to kind of worry. So just try hard, right? That's all you have to do. Right. Now the correct answer is 375 joules. එහෙනම් මෙතන ඉඳන් point C ඉඳන් A ට බෝලයක් අරන් යනවා නම් ඔයාලා මෙච්චර කාර්ය කරන්න ඕන. හරි? ජූල් 375ක කාර්යයක් කරන්න ඕන. Right. So then the next question is, what is the amount of work you should do if you move from point B to point A? Right. Earlier, what you did was, right, point B to point A. Earlier, you moved from the reference level. So now this is your reference level. Reference level. Or as the ground. We call the same as ground. Ground, right? Ground level. This is the point C is the ground level. And you move from ground to the point A. Now we are going to give this energy level a new name, that is the potential of that point, right? Potential of point A. Potential of point. Potential of the point, right? I'm going to give new name. Right, I'm going to erase everything. Right, so you multiply the mass from the potential of that point. Now, how can you calculate the amount of work you need to do from point? Thank you for the answer. I believe I'm getting many correct answers. So let me explain that again. So now the second question, first question you already know. So what you had to do is you are moving from reference point, ground point, to another point, and that other point, the potential level is given in reference to this starting point. So there was no problem. Now the second problem, you are moving from point B to A, which is not your reference. Point B එක නෙමෙයි reference එක. ඉස්සෙල්ලා නම් C reference එකෙන් තමයි move කරේ, ප්‍රශ්නයක් වුණේ නැහැ. දැන් මෙතන reference එක point B නෙවෙයි. In that case, how can you calculate the amount of work you should do in order to move the same load from point B to A? So you have to use a different equation like this. In this case, you have to multiply mass by the potential difference, right? Potential difference. This is you are going to kind of you are multiplying by the potential difference. Let me erase and rewrite that equation, right? Or maybe I can take a different screen here. So earlier you multiplied the mass value multiplied by the potential of the point. right? So this was the equation you used earlier, and now you have to use this other equation where you have to multiply the mass by the potential difference. Right? So when you move from the reference point to some other point, you use this first equation, and now in this case you are moving from a point which is not the reference to another, you have to use this second equation, right? And again there is another answer, I believe. B to A is 250 joule amount of work you need to do. Now let's see how. You take the potential difference, which means the difference between these two levels. So potential at point A is 1.5 joule per kilogram, minus here the potential is 0.5 joule per kilogram. So the difference is, the difference between the two potentials are 1 joule per kilogram, right? Then you would simply multiply this 1 joule per kilogram, because you are moving from B to A, from this mass value, that is 250 kilogram multiplied by 1 joule per kilogram. So these are going to cancel out. The work is 150 joule. This is J here. So this is the amount of work. So you can easily calculate by using the potential difference. In fact, in the first equation as well, you did the same thing. That is like in second equation, you took potential difference, and fortunately, the potential at point C is always zero. So if you go back to the C to A problem, so there as well, what you did was something like this, right? So you took the potential difference, that is 1.5 minus 0. So you multiplied that by the 250, right? So the good thing about the reference point is its potential is 0. Therefore, you don't have to worry about the potential different. Instead, you can directly take the potential at that point and multiply, right? When you move load from ground point to some other. But when you think of two other points, you have to think of the potential difference, right? In other words, the potential at a point means the potential difference in reference to the ground point, right? So සිංහල පොඩ්ඩක් ගාලා කියන්න. මෙතන C වල ඉඳන් A ට මේවා කරද්දිත් ඇත්තටම මේ දෙවෙනි ඉක්වේෂන් එක තමයි යූස් වුනේ. එතනදී potential difference එක මෙතන ground point එකේ potential එක බිඳුව හින්දා කෙලින්ම මේ A point එකේ potential එකට සමාන වුණා. 5 1.5 අඩු කිරීම බිඳුව කියන්නේ කෙලින්ම 1.5. හරිද? එහෙනම් වෙනස් විදිහකට කියනවා නම් මොකක් හරි point එකක potential එක කියන්නේ ground point එක නැත්නම් reference point එකට සාපේක්ෂව potential difference එක. right? ඒකයි අපිට කෙලින්ම mass එකෙන් වැඩි කරපුවාම උත්තරේ හම්බෙන්නේ. හැබැයි මේ point දෙක අතර ඒ වගේ A සහ B point දෙකක් අතර ගන්නකොට ඒකේ A වත් B වත් reference point එක නෙමෙයි. ඒක නිසා අපිට potential difference එක ආපහු calculate කරන්න වෙනවා. ඒක මෙතන calculate කරනවා 1.5 minus 0.5 is equal to 1 joule per kilogram. So that way you can calculate. Right? I hope that's clear. And now think of this situation at point D. So you were earlier at ground level, right? Here, this is the ground level, beam bottom. Now you go below ground level, which means maybe you are going to excavate a pit or something. And you name this potential level here is, let's say, okay, 0.2 joule per kilogram, which means and it has to be minus because the point is kind of below the ground point. මේක ground point එකකට යටින් තියෙන. ඒක නිසා මෙතනින් මෙහාට ඔයා මොනවා හරි වස්තුවක් කරන් යද්දී ඔයා කාර්ය කරන්න ඕනේ. කෙලින්ම you directly come to this edge and release the load, so it's going to fall, right? Wallයක් හරි මොකක් හරි මෙතන දාන්න ඕන. කෙලින්ම අතාරපු ගමන් because of the gravitational forces it's just going to fall. So which means it's doing work for us. ඒකෙන් කාර්ය කරනවා. අපි කාර්ය කරන්න ඕනේ නැහැ. ඒකෙන් කාර්ය කරනවා, right? So if someone would come and ask you to you the amount of energy you should do, it's negative, right? That's why this mark here is negative. I hope these things you already know, right? Let's now go back to our circuit, right? In our circuit as well, so we have two resistors and a battery of 5 volt, 1 ohm resistor and 4 ohm resistor, right? And now the electromotive force is something like gravitational force, right? There is an attraction force, right? Something called as the electrical field here. Now what they do is there are negative charges here and positive charge at the other side. The positive charge or as negative charge ask the other types of charge to meet them somehow, right? So what they would do is they would come along these conductor paths and meet this opposite charge, right? In fact, it is what it is happening is the electrons are flowing to the positive place, right? So that is same as a positive charge is coming to the other side. So here as well, this voltage is defined as the amount of work you should do, which means joule per coulomb, 1 coulomb charge. So which means a 5 voltage battery means, right, if a charge of 1 coulomb is released from this side to the other, an energy amount of 5 joule will be released, right? So like in this case, so if a ball of 1 kilogram was released from here, what would happen is 1.5 joule would be released if it once it reaches this ground level. Something like that is happening here, right? So people have forcefully separated the charges in the battery, right, by using chemical reactions, and once you release that energy, it's like that we forcefully brought our loads from here to this, from point C to point A. Likewise in the battery the charges are separated, and once they are released they are going to their original ground level, and the charges are going to their low potential level and while releasing energy. That's what it is happening in a circuit, right? Now like in this case, usually the negative pin of the battery we name as the ground level, right? Ground. So which means we say, okay, potential at here is 0. 0 volt means joules per coulomb, right? And now for a battery, 5 voltage means the potential at this other point, I'm going to color it this other level like this, right? It is same because there is no potential difference in a conductor, and it is 5 volt, which means 5 joules per coulomb, right? Right. Now with the basic knowledge you know, can you calculate the current through this circuit? Calculate the current through this circuit, I value, and let me know what is the current value. Calculate and send me the answer for current value. Right. As you know, you have to simply apply V equals. Thank you for the answers. I get many correct answers. And yes, both are correct answers. You are going to apply V equals IR. Right. There is an answer which is not correct, but still thank you for the answer. Right. So V equals IR. V is 5 volt. And I don't know. R is 1 plus this resistance is 4. 1 plus 4 is 5 ohms again. Therefore, I is going to be 5 divided by 5, which is 1 ampere. Right? So that is the current. That is the amount of current. Right? So the value of I is 1 ampere. Right? Now, you know an ampere means coulombs per second. For 1 second time period, it has a flow of 1 coulomb charge in this circuit. Right? Now, can you calculate? So now this is the ground level. Right? This is the ground level. Right. Now, can you calculate this, the amount of charges, amount of energy this circuit releases for 2 seconds, right? Or let's say for 1 second, for 1 second time period, the amount of energy that this circuit releases. Can you calculate? For 1 second time period. තප්පරයක් ඇතුළත මේ circuit එක release කරන energy ප්‍රමාණය දැන් calculate කරන්න පුළුවන්. තප්පරයක් ඇතුළත මේ circuit එක release කරන energy ප්‍රමාණය. Right. As student says, it's 1.5 volt. That is the correct answer. Why? Now during 1 second, the total amount of charges going through this circuit is how much? It's 1 coulomb per second. And if you multiply it by 1 second, right? When you multiply this thing by 1 second, the amount of charges going for a period of 1 second is equal to 1 coulomb, right? Which means you are moving a 1 coulomb charge from this plate to this plate during 1 second. And once you move 1 coulomb from this level to this level, it releases an amount of 5 joules per coulomb. So you multiply it by 1 coulomb, you get 5 joules, right? 5 joules. And it releases 5 joules. So during 1 second period, this circuit releases an energy amount of 5 joules, right? And your answer should be in joules, not in watt, because I asked you what is the amount of energy this circuit releases during 1 second period. මම ප්‍රශ්නේ අහුවේ තප්පරයකදී මේ සර්කිට් එක රිලීස් කරන එනර්ජි ප්‍රමාණය කොච්චරද කියලා. දැන් ඒක තේරුම් ගන්නවා නම් මේකේ කරන්ට් එක කොච්චර ඇම්පියර් 1යි. හරිද? ඇම්පියර් 1යි. අපි දන්න දත්ත ටික මම මේ කියන්නේ. හරිද? ඇම්පියර් 1යි. ඇම්පියර් 1යි. දැන් මම සංසන්දනය කරනවා මේ සිටුේෂන් එක මගේ පඩි පෙළත් එක්ක. right? So කරන්ට් එක ඇම්පියර් 1යි. ඇම්පියර් 1යි කියන්නේ තප්පරයකට කූලෝම් 1යි. හරිද? මම සලකනු ලබන පීරියඩ් එක තමයි තප්පරයක පීරියඩ් එකක්. එහෙනම් මේ පැත්තේ ධන ඉඳන් ඍණට ආපු charge එක මම හිතුවොත් කූලෝම් 1යි. ඒක හොයාගන්න. ඊළඟට ඒ කියන්නේ මේ වගේ කතාවක්. තප්පරයකට කිලෝග්‍රෑම් A වල ඉඳන් B වලට කොච්චරක් එනවද වගේ එකක් තමයි මම කැල්කියුලේට් කරන්නේ. හරි? තප්පරයකට කිලෝග්‍රෑම් කීයද වගේ. right coulomb කොච්චර ඊට පස්සේ මම බලනවා මේ level එකේ ඉඳන් මෙතනට එද්දි කොච්චරක් energy release වෙනවද coulomb එකකට ඒක හරියට මෙතන ඉඳන් මෙතනට එද්දි A වල ඉඳන් B වලට කියලා හිතමු එද්දි කොච්චරක් කිලෝග්‍රෑම් එකකට energy release වුණාද ඒ වගේ ප්‍රශ්නයක් තමයි එතකොට මෙතනදී අපි දන්නවා volt කියන්නේ වෙනස් විදිහකට කිව්වොත් joules per coulomb එහෙනම් මේ point එකේ potential එක නැත්තම් මෙතන අපි මේ level එකේ potential එක දුන්නානේ ඒ වගේ මේ නිල් පාට කලර් කරලා තියෙන සම්පූර්ණ එක level එකක් conductor එකක් හින්දා මේ conductor එක පුරාවට තියෙන එකම level එක හරියට මේ පොළොව සමතලයි වගේ conductors වල voltage drops නැහැ right potential drops නැහැ potential එක drop වෙන්නේ නැහැ conductor එක පුරාවට එතකොට මේක එක point එකක් මම මේක A point එක කියලා නම් කරොත් හරිද point A එකේ potential එක 5 volt නැත්තම් 5 joules per kilogram per coulomb coulomb එකකට joule 5ක් කරන්න ඕනේ මේ ground එකේ ඉඳන් මෙතනට charges coulomb එකක් ගේන්න ඕනේ එහෙනම් release වෙන්නේ තේ ප්‍රමාණය වුණා එහෙනම් මම කරන වැඩේ තමයි 5 joules work එක release වෙන coulomb එකකට එහෙනම් මම ගෙනාවේ කොච්චරද දැන් තප්පරයකදී තප්පරයකදී මම මෙච්චර ප්‍රමාණයක් ගෙනාවා එහෙනම් ඒකෙන් වැඩි කරනවා එහෙනම් සම්පූර්ණ ප්‍රමාණය coulomb to coulomb කැපිලා යනවා 5 joules work එකක් තමයි වෙන්නේ තප්පරයකදී right මේක තමයි energy එක release වෙච්ච now මම coulomb 5ක් ගෙනාවොත් මම potential එකෙන් B එකට coulomb 5ක් ගෙනවා I am going to bring 5 coulombs of charge from point A to ground point right point A to ground point calculate the amount of energy from point A to point ground point right so the battery is going to discharge a charge amount of 5 coulomb so calculate the amount of energy released the battery is going to discharge 5 coulomb so what is the amount of energy right let's see if you have understood the concept there are several answers not all the answers are correct but thank you for the answers and there is one answer which is correct right so it is like this situation here right we have defined the potential here as 5 volt which means 5 joules per coulomb right 5 joules per coulomb coulomb එකකට joule 5ක් කාර්යයක් කරන්න ඕනේ A වල ඉඳන් ground වල ඉඳන් A ට ගේනවා නම් නැත්නම් A වල ඉඳන් ground එකට යනවා නම් joule 5ක් කාර්යයක් කරනවා now what it is happening is the circuit is doing work for us and it does a work of 5 joule if you move from point A to ground right and we are moving an actual amount of 5 coulomb so simply multiply it by 5 coulomb that is going to be 25 amount of joules right 25 joules of work is done by the circuit right again now calculate the voltage drop calculate the voltage drop across 1 ohm resistance V1 and across 4 ohm resistance V4 V2 sorry මෙතන voltage drop එක 1 ohm resistor හරහා සහ 4 ohm resistor හරහා calculate කරන්න right so I've got the correct answers thank you for the answers V1 is 1 volt V2 is 4 volt. So what you're simply doing is applying V equals IR equation, right? So this is something you have known for many years, right? But what does it really mean, right? So this is like in this situation, what you have just calculated is the potential difference. So let's name this point as, I'm going to name these points. So this entire conductor here, I'm going to name as point B, right? So if I draw an staircase for this situation, right? So this blue color part here is in blue, and the yellow part is there. The ground potential is here. And this is point A. This is point B. This is ground, right? And at the ground level, the potential is 0 volt. In other words, 0 joules per coulomb. Here, it's 4 volt higher than that. So the voltage dropped because the first resistance. Now this 4 ohm resistance is here. It's like the height. 4 ohm resistance is here. This is the 1 ohm resistance. Right? So the potential here is 4 volt. The potential here is 5 volt. Sorry. Here it is 5 volt. Right? So now what you have calculated here is the potential difference. So now you should understand difference between potential and potential difference. So potential means actually the potential difference in reference to ground. Ground එකට සාපේක්ෂව potential difference එකට තමයි අපි නමක් දෙන්නේ potential එක කියලා. So you choose the reference point as you want, right? You take this lowest point as the ground, the lowest possible point as the ground. එන්න පුළුවන් අඩුමගේ ground එක කියලා ගත්තා. එතකොට ඍණාගයන් එන්නේ නැහැ. ඒක හින්දා ඒක ground එක කියලා නම් කරා. ඒකට සාපේක්ෂව අනිත් points වල potential එක ඔයා potential difference එක ඔයා potential එක කියලා නම් කරනවා. So in reference to this point, the difference here is between B and ground point is 4 volt, between A and ground point is 5 volt, right? So potential difference means it's like one depends over the other, the definition, right? So it's the difference simply of the potential, right? So here it's 5, here this is 4, so the difference is 1. So the difference is 1 volt. So, or as the drop across 1 ohm resistance is 1 volt. And here point B is 4, this is 0. So the difference is 4. In other words, the drop is 4 volt, right? 4 volt drop, 1 volt drop, right? So by voltage drop, you mean a potential difference. Potential difference. You can now understand, I believe. So the voltage is going to drop. Here as well, it's going to drop. So across resistors, the voltage will drop. So this is the kind of the analogy between the potential energy scenario in the real world example and an electrical circuit, right? So if you have any questions, you can ask now. And thank you for the correct answers. So I mean, few students have sent the answers, the 4 volt and 1 volt, right? So I'm going. What I did was like I compared this circuit with our staircase here, right? And I gave the potential levels at each point, right? Then what we have really calculated as voltage drop is the potential difference, right? It is equal to the voltage drop is the potential difference. And we have named our own ground point. And in reference to that, we have calculated the potential at other points, right? Now let's go to the electrical terms, right? What you have to do is quickly calculate for me. I'm going to change these values. I'm going to take a different circuit here, which has 3 resistors and a battery of 6 volt. Resistor is 1 ohm, this is 3 ohm, this is 2 ohm, right? So what I want you to do is I'm going to name these points as, this is point A, this is point B, this is point C, this is point D, right? And you can take your own ground point, right, as you prefer, and calculate VAB, VB, VC, right? So VAB means B in reference to B, the voltage at A. In other words, in reference to B, the voltage at A. In reference to B, the voltage at A means if you move from point B to A, what is the voltage difference from B to A, right? And you also have to calculate VBA at the end. Okay, maybe you also have to calculate VBA. So for now, send the answer for first question. What is VAB? What is VAB? Calculate VAB. So VAB is 1 volt, right? So let me quickly I'm going to use different colors for your convenience. And if I compare this situation here with the staircase, maybe I can have right. So these are the different levels. This is point A level, this is ground level, this is point C level, and this is point D level. So if I name them, this is A, this is B, this is C, this is D. And the first question is, what is VAB? Which means you are moving from B to A. So the term that comes second is the starting point, right? You are moving from B to A. So at that case, so the first thing you have to do is you have to calculate these potential levels. In order to calculate them, you need to know the current. So you know it's V equals IR. So the total resistance here is 6 ohms. So as earlier in the earlier case, you should get the answer. Current is 1 ampere. And in that way, you can calculate the potential here is, of course, potential at A, you already know that is 6 volt, and here you can calculate the drop from B to A, you know, okay, drop here, so that is IR again. So 1 times 1 is 1 volt, so the drop here is 1 volt, so which means the potential here should be 5 volt. And you come from B to C, there the voltage drop here is 3 volt, this is 1 volt, so which means from here to here it is 3 volt, which means from 5 to 3 the potential here should be 2 volt, and you go from there to there, the drop is 2 volt, you or don't have to apply equation V equals IR here, because from the graph it is clear, since this voltage level is 0, so you don't have to calculate the drop here. Metra voltage drop to calculate can on it now, because all the levels you already know, right? All the things are known. Now the first question is VAB, right? That is okay. Thank you. There are correct answers, I believe. So let's check, right? Thank you for the answers. You move from point B to A. You move from B to A, which means from here to here. The difference is higher, right? Which means you reduce VA minus VB. That is the idea. So the second letter comes as the second term, right? That is 6 minus 5 is 1 volt. So the first answer is 1 volt. You should get, if you have got that answer, that you are correct. And the second answer is VB. VB is the potential here. It is 5 volt. Potential here is 5 volt. So the first question is about the difference. So this is the difference, and this is just the potential. මෙතන අහන්නේ වෙනසක් ගැන පළවෙනි එකේදී VAB කියලා දෙකක් දාලා තියෙන දෙකකින් ඉඳන් මෙතන කෙලින්ම කියන්නේ potential එක ගැන. මෙතන potential එක C point එකේ 2 volt. VBA in the sense you start from A and move to B, right? Which means you start from A move to B means VB minus VA. That is 5 minus 6. That is minus 1 volt, right? So don't forget the minus sign. So you should get the idea, okay, VAB is equal to minus VBA, right? Maybe you can note down that as well if you want, right? So there's nothing much, so it's really simple. If you have any questions, you can ask now. So many has sent the correct answers, and I'm really happy about that. And now what you need to understand here is the terms potential difference, voltage drop, electromotive force. Those are the things we discussed. And the other thing is the ground reference. So in this case, you took this as your zero reference, right? And quickly, let me tell you, one can take instead this point, this as the ground reference, right? He says, okay, this is my 0 volt point, which means he takes point C as the ground. He is going to ground his circuit from point C, right? In that case, for that person, he would get the point D potential as minus 2 volt. Here, this voltage as 3 volt. This voltage as 4 volt. හැමතිස්සෙම අඩුමක් ගන්න ඕන කියලා කතාවක් නැහැ. සමහර විට කෙනෙක් point C එක reference point එක කියලා ගත්තා. එයා එතනට සාපේක්ෂව තමයි අනිත් values කියන්නේ. එතකොට එයාට මෙතන එනවා ඍණ දෙකක්. මොකද මෙතන ඉඳන් මෙහෙට යද්දි ඍණ දෙකක් වෙනවා. හරියට අපේ මේ මෙතන problem එකේ මෙහෙට කාර්ය කරද්දි ඍණ. ඒ වගේම තමයි ඍණ දෙකක් වෙනවා. මෙතන ඉඳන් point C වල ඉඳන් D වලට යද්දි මෙන්න මේ point එක යට 3 volt කියලා එනවා. එතකොට මේ උඩ point එක 4 volt කියලා එනවා. ඒ කියන්නේ මේක 0 කියලා හිතුවොත් මේ level එක 0 කියලා හිතුවොත් එයාට එන්නේ වෙනස් values. Right? එයාට එන්නේ මේවට වෙනස් values. Potential වලට වෙනස් values. But still the potential difference, right? Potential difference would be the same. 4 minus 3 is 1 volt. 4 minus 3 is 1 volt. And the other way is minus 1 volt. So potential difference would be the same depending on the ground position, but potential may be different, right? VB for this guy is going to be 3 volt, and VC is going to be 0 volt. VC is 0 volt because it is his ground reference, right? I hope that is clear. And if you have any questions, you can keep those questions for the next time. And thank you for being here. I'm going to end the lecture now. Please, if you have any questions, feel free to send me a mail. Maybe you can WhatsApp me, and or you can ask your questions in the next lecture. All right. I'm going to end the lecture today. We have a meeting here, and I have uploaded all the videos. I'm going to upload this one as well. So please let me know if you have any problem or any other issue regarding your academic matters and LMS access. Right. Thank you very much again for being here. I hope that you understood the concept of electromotive force, potential and potential difference, and you should have this intuitive idea about electrical circuits in some situations in order to understand the circuits better, right? So next time we will discuss about AC systems in detail. Please try to refresh your memory on sinusoidal functions and other things. This entire subject is almost dependent on this trigonometric problems. I have uploaded the lectures. Please check and let me know if they are not there. Right? If you cannot access, please let me know. So a student is asking to upload the lectures. I have already uploaded. Yesterday as well, I got a kind of a comment or as a complaint, but I have uploaded. Please let me know if you cannot access. Right? In my account, so I have a teacher's account. It shows that they are uploaded and accessible, but I don't know what it is happening in your student accounts, right? So please let me know if they are not working. You know my phone number and you know my email address, so please let me know, right? Okay, thank you very much again for being here.